We're in section 9.5, the distance and midpoint formulas. You do have to have these formulas memorized. They seem really large and like very difficult at first, but I promise you once you do the homework assignment and you write it a couple times, it will become a lot more second nature to you. All right, so we're using these formulas, and what does it mean? It's basically helping us find, and you don't have to write any of this down, the distance between 2 points in a coordinate plane. Okay, and there's just a formula that I can use to find that. So in example 1, we're finding the distance between points M and points N. The first thing we need to understand, and we actually did this when we were finding slope, is how do we number each one of the points in these ordered pairs? And it goes x1, y1, x2, y2. Okay, so that's how we're going to number the points. Go ahead and write that first set down. Point M, its location is at 6, 3, and point N is at 5, 7. Go ahead and write down those two ordered pairs. Okay, so now let's go back to the formula. The formula you have to write down. Go ahead and write this formula under those ordered pairs. D equals the square root, a big long square root, of x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared. Okay, that's my formula. All right, so now let's go back to example 1. Guys, hush. Okay, so I'm going to write down my formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Again, the more you write that, the easier it'll be to remember. Which value is x2? Which number in these ordered pairs is x2? Very good. So I'm going to put 5 in parentheses minus, what's my x1 value? 6 squared plus, what's my y2 value? 7 minus, what's my y1 value? 3 squared. Now I need to simplify what's in the parentheses. The square root of negative 1 squared plus 4 squared. Now, guys, you can put this in your calculator, but make sure that you put that negative number in parentheses before you square it. If you do not put it in parentheses, it will give you the wrong answer. So now, this is the square root of 1 plus 16, which is the square root of 17. So the distance between these 2 points, find the square root of 17. Oh, we just leave it square root of 17. Distance equals the square root of 17. Because are there any perfect square factors in the number 17? If I put the square root of 17 in my calculator, what do I get? 17. I get 17. Okay, so since there are no perfect square factors, that's my simplified answer, and I'm done. All right, so just lots of substitutions. Actually, once you make your substitution, you can just put the entire thing in your calculator. That's fine, but I need to see formula, substitution, and then your boxed answer. Go ahead and try the second one, guys, and watch for, actually do the third one, because I want to work with double negatives. On the third one, you're actually going to have some double negatives, so make sure you catch that and you make them positive. All right, so now let's make our substitutions. What's my x2 value? Negative 4 minus negative 1 squared plus y2, which is 1 minus 5 squared. What happens to that double negative, guys? Changes to a positive. So now it's negative 4 plus 1, which is negative 3 squared plus negative 4 squared. So the square root of 9 plus 16, so D equals, what's the square root of 25? 5. D equals 5. All right, any questions on finding distance? All right, moving on to the next example. In example 2, now I'm using the distance formula to solve. So it says a bird watcher uses a grid to photograph and record the locations of birds feeding on the ground. The grid is made of fishing nets with strands that are a foot apart. How far apart are the birds at points A and B? So here it does not actually give me the coordinates for A and B, but could I read the graph to find the coordinates? Yes. So go ahead and read the graph to tell me what are the coordinates for A and B. All right, so go ahead and write it on your paper. So what's the coordinate for point A?
3 and 2.
A is what?
3, 2.
3. 3 and positive 2. Yeah, it's positive. 3, 2, and then B. These are all positive. See where 0 is? Okay, so to the left would be negative and down would be negative. These are all positive. All right, so B is what?
7.
Yeah, and think about it. Can there be negative times or negative distances? No. All right, so B is 7, 5, you said? Okay, so now use these points to find the distance. So plug these values into the distance formula now. Make sure you rewrite the formula. I know it's a pain, but it'll help you learn it. All right, so we make our substitutions. Square root of, what's my x2? 7 minus 3 squared plus, what's my y2? 5 minus 2 squared. Okay, so that's going to be the square root of 4 squared plus 3 squared. This is actually going to be the same answer, just a different setup. Square root of 25. So D equals 5 again. 5 what? Yep, 5 feet. So I found all that out by using the distance formula. Okay, so now in example 3, I'm using the midpoint formula. The midpoint formula is M equals parentheses x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Okay, so whatever those values are will actually make up an ordered pair that is the midpoint between two points. All right, so my midpoint formula. Oh, sorry. Okay, so now let's find the midpoint. All right, so here's my two ordered pairs, 3, 8, and -9, -4. So I'm going to plug those into my formula. Remember, it's x1 plus x2. You don't have to rewrite it because you just wrote it once, over y1 plus y2 over 2. Okay, so plug in your numbers. All right, so making our substitutions, we're going to have x1. What's my x1 value? 3 plus -9 over 2, and 8 plus -4 over 2. Now, plus and negative is the same thing as what? Subtracting it, okay? So 3 plus -9 is the same thing as 3 minus 9. So that's -6 over 2 and 4 over 2. Can I simplify those? Yes. What can I simplify it to?
3, 2.
-3, 2, and that's the midpoint. I'm just going to squeeze it in up here. -3, 2, and that's my answer. That's my midpoint between those 2 points, -3, 2. All right, you think you can do, let's do, doesn't matter. Let's do the third one. Okay, let's do the third one. Find the midpoint of the segment with endpoints -4, 3, and 3, -3. Okay, so formula, it's going to be x1. I don't want to write it in red. All right, so x1, which is -4, plus x2 over 2, and then y1 plus y2 over 2. So what's -4 plus 3? -1 over 2. And what's 3 minus 3? 0 over 2. So what's 0 over 2? 0. So -1/2 and 0 is the midpoint. Did you get it? -1/2 and 0? All right, so those are my midpoints. That's how I find midpoint. Now the last thing I need to learn, and good news, you've already learned this one. I already taught this to you, to find slope. To find the slope, my formula is y2 minus y1 over x2 minus x1. Okay, so here we go. Find the slope of the line that passes through. We're just going to do one of these. Through points 3, 7, and 8, -3. So again, what is my formula? y2 minus y1 over x2 minus x1. Plug in your numbers and find the slope. What's my y2 value? -3. What's my y1? -7 over 8 minus 3 equals -10 over 5, which is -2. Who got -2? Awesome, good job. All right, so find the slope. So I'm changing your homework. Here's your homework. All right, so I'm making it fewer problems, but we're going to cover different problems. It's going to be lesson 9.5, page 479 to 480. Numbers 12, 14, 28, 30,
Teachers, please pardon the interruption. Students, I just want to remind you for
34,
your SAT test tomorrow to please bring
and
a
35.
calculator and 2 number 2 pencils.
All right, and if I understand that, that's everything you need to know for
And 2
9.5.
number 2 pencils. Thank you.